We're just like literally scrolling.
I didn't hear the sound yet that says it's on.
I think it's
College cross.
I think it is, but there we go. All right. Today we're doing 24-1. Well, I guess I'll read it so that it's recorded. Go ahead and follow along with paragraph on 371. Wesley is researching college costs. He is considering two schools, a 4-year private college where tuition and fees for the current year cost about $24,000, and a 4-year public university where tuition and fees for the current year cost about $10,000. Wesley learned that over the last decade, tuition and fees have increased an average of 5.6% per year in a 4-year private college, and an average of 7.1% per year in a 4-year public college. To answer items 1 through 4, assume that the tuition and fees continue to increase at the same average rate per year as in the last decade. So we have the starting amount of $24,000. We'll work with just the first column. That is for private colleges. Let's read what it says about private colleges. Average of 5.6% per year increase for private colleges. So how do I find the new amount for next year? Lydia?
5.6%.
Okay, so let me write 5.6 real quick. I want 5.6% of 24,000. We know when we put it in our calculator, we have to move the decimal twice. So we're going to do 0.056 times 24,000. Start with that. 0.056 times 24,000. I get 1,344. So the first year it's 24, or to begin it's 24,000. The next year it's only 1,300. That can't be right. What is that number? That's the amount that was added. So I'm going to have to take that amount and add 24,000. So I get what? 25 what? 344. Pause for a second. What you're doing is not wrong. It's not the best way. It's not the best way because we don't want to have to get a number. That's a step. And then add that number to 24,000. That's 2 steps for every single box that we have to do. Do we know a quicker way besides finding the increase and then adding the increase, which is 2 steps?
You do 1.056?
Yes. Right. Here's why that works. Because this is just the increase percent. But I already have to pay the 24,000. I have to pay 100% of the previous year. I have to pay 100% of that and an additional 5.6%. So instead of doing this separate and then adding it to the 2,400, if I have 100% and 5.6%, I have 105.6% of, which means times, of the previous year. Does that make sense? Move the decimal 2 times. That's where we get our 1.056. Now it's 1 step. You multiply by one number, 1.056, and you get that number. For the next year, do I multiply by 1.056 again? Yes, because I want 100% of the previous year plus the additional 5.6%. So every time you're multiplying by 1.056. Did you know once you type times 1.056, 2 or 3 times. If you just hit enter, your calculator knows it's what you want it to do. If you keep telling your calculator to do the same thing, eventually, if you just hit enter, it knows to do the same thing again. It's like a smart calculator, only it doesn't have internet. It's just smart. Hopefully that completes your first column. The next column is public colleges, and that increases at 7.1% each year. So if I move that twice, that's 0.071. Is that what I want to multiply by? I want to multiply by 100% plus an additional 7%. So just like before, 10,000 times 1.071 every time times 1.071. We're talking money, so it would make sense to round to the nearest hundredth. We are going to skip number 2, but it says, nope, not skip 2. We're going to skip 3. So let's do number 2. Write 2 functions to model the data in the table. Let R of t represent the private. So let's put R of t above this one. And U of t represent public. See if you can write an equation for each of those columns. If you get an answer, an equation, plug, say, 4 into your equation. You should know if you got the right one. I want to see. Yep. Oh, wait. That says plus. Yep. So a lot of us are really good at writing linear equations. Is this one linear?
No, it's
No, it would have to go by the same thing every time. This is going up by the same multiple, which is exponential. So we know that exponentials look like this. The y-intercept. So the first one, the y-intercept or starting value was 24,000. And then whatever you multiply by every time, we multiply 1.056. Try to put it to the t power instead of x, since that's what it tells us to use. And then our other one, our initial value, 10,000, 1.071 t. Questions on the equations? How many of you were successful before I told you the answers?
pretty successful.
Yes. Although you would have known when you plugged in 4 that something was wrong, and you probably would have found it yourself. Always a good idea on a quiz or test. When you are writing equations, because a lot of us are not super confident with that, plug in a t value you know. You can do 1, 2, 3, or 4. You should tell if the output is correct. Number 3, which is one we're skipping, just says how much is it going to be in 6 years, which I don't think we really need to take time to plug 6 in and find the costs. So we're going to go to number 4. Write an equation that can be solved to predict the number of years it will take for the public college tuition and fees to reach the current private tuition and fees of $24,000. We'll worry about finding the solution and everything after that. I want you to write the equation. You might have to read it again. Write what you think for number 4.
Have a good day.
I will read it again. An equation that we solve to predict the number of years it will take for the public, which is U of T, the second column, to reach 24,000. Well, I want this to reach, oopsies, 24,000. That's all you have to do. Take the current equation. We want to know when it equals the start, the 24,000. Let's talk about this problem for a little bit. If I asked you to solve this algebraically, like x is here, but there's a t, that is not something we've learned yet. Something we're going to learn next week. But do you have an idea on maybe the first thing you might do to get t by itself? Julian?
Divide by 10,000.
Yeah. If we were solving this, you don't have to write this down. You would probably want to get rid of the 10,000, which is being multiplied. So one, not these parentheses anymore. 1.071 to the t. What is this? Now, think about if you have any guesses on how to get t by itself.
Since it's going to the power of t, you'll have to find like the square root, or not like necessarily the square root, but you have to root it by whatever t is equal to.
Okay. Jonathan, what do you think?
Just take the log. Solve it for t log.
Okay. Julian?
I think you do log base 1.071 on both sides, and then you have like log base 1.071 times of 24 or 2.4.
Yeah. Very good ideas. So let me start with the sort of square root type thing. You know it's not square root, which is what you mentioned, because that's not squared. But she's thinking, it's kind of like a power. That works if I have a number here. This is 5. I take the 5th root squared, take the 2nd root. I can't really take the t root. So that's a good guess. Somebody mentioned that last hour too. Oh. So what these two mentioned is correct. We're not going to get into it too much now because we're going to do it next week. But the inverse of the exponent, which we've been talking about, is logs. So if you have an exponent, just like if you have addition, you get rid of it by subtraction. You have squared, you do square root. You have times, you do divide. If we have an exponent, the inverse of exponent is logs. So we would use logs. In this case, this is the base of our exponent. So I would have to do a log with that base. Couldn't I type this in my calculator? Log base 1.071 equals 2.4. That'd be a number, right? If I have a log with this base and an exponent of this base, doesn't that cancel? And I've got my variable by itself. So it looks kind of complicated. When we do it, you'll start to figure out it's not too bad. It's a lot like if you add, subtract, if you multiply, divide, you just do the inverse. Oopsies. So that's kind of what we're going to get into. So let's pretend we didn't know that. I'm going to go over some other ways to solve for t. Your book mentioned the calculator. So here's what we're going to do. We're going to type this into y1 and this into y2. You won't have a t, but you can do x. So y1, 10,000 times 1.071. Remember, it's the caret right above divide. Then you'll have to use x, which is by alpha. Y2, 24,000. We'll get into that. Here's what my graph looks like. It's a great graph of college tuition, isn't it?
Yeah.
Why is that a great graph of college tuition? Why isn't it there?
Because college tuition
Because college tuition doesn't go from negative $10 to $10. So let's make adjustments. Let's look at what our X and Y stand for. I'm going to go back to my equations. What is X or T, the input, represent?
Year.
Years. So go to your window. X is years. Your current years say negative 10 years. What would we like to change our lowest years to? 0 sounds good. And we don't know our years, but we know, according to our table, we know at 4 years, we'll be at 13,000. We're trying to get to 24,000. So we just need a ballpark, and if it's not big enough, we can fix it later. So we know it's bigger than 4 years, probably not 1,000 years. We need a good guess. So who's got a good guess for a number of years?
I think guesstimate about 8.
Okay, let's do 8. What does Y stand for?
Money.
Money. Now, we're not going to have $0, right? But we're definitely not going to have negative 10. I would just put 0. Sometimes it's just nice to have the origin in my graph. How high is the money going to go?
24,000.
Yeah, we don't want our cutoff to be the very edge, tippy top of our graph. So you can do 25,000, 28,000, 30,000. I'm going to go with 30,000. Something bigger than 24,000. Let's see. Ooh, they don't touch. So that means we need to expand our graph. Do we need our graph to get higher in the Y or farther in the X? Farther in the X. So a good guess of 8, but we need to go bigger than 8. What do we want to try? 12?
15, actually. 15.
I hear a 30. Let's go big, and then we'll make it smaller if we have to. 30. Ooh.
I put 15.
15 works too. Now they touch. So this means the blue graph is my tuition rising over time. And this line is always at 24,000.
I have 14.
So wherever they touch is when it reaches 24,000. Here's how you find that without guessing. Hit second. And then up by trace here, above trace, it says calculate. Second, calculate. We want to calculate intersect. Does anybody need more time? You're not there. Don't want to give more steps if you're behind.
I try to do this stuff on the quiz, and I get like so confused, and then I just like think I break the calculator and give up.
It says first curve. So you want to move your cursor. Just hit left and right. I don't think you want to hit up and down. Until you get close to the intersection and hit enter. Usually your second curve will just already be near that spot, so you can hit enter again. If you ever mess up, just start over. Second, calculate, intersect. We don't want to guess, so hit enter again. There's your intersection. At 12.76 years, we will reach a tuition of 24,000. So essentially the 13th year. Somewhere in your book, write down these conclusions.
It's not.
I would write the decimal we got, and then I would say at the 13th year, we would surpass the 24,000. One second. I'm going to rewrite this a little bit neater.
Yeah. It's not entering.
Chill out. I'll be there in a second.
I did second curve and the first curve, and I hit enter.
Does it say yes?
No.
Okay, let me see. Okay, hit enter. Just start over, hit second calculate. You might have hit up, and then if you hit up, it might go off of your curve. Yeah, hit left and right. Enter. Enter. That's what you know. There you go. All right. You can just look up here for a second. We have talked about how to do this algebraically. We sort of introed it. We said it's for next week. Algebraically, you could solve for t. We would divide. We would do a log. One thing we've just discovered is using a calculator, we could graph this and see where they are equal or touch. Another way with your calculator is to look at the table. So hit second table, which is above graph. The reason Y2 is 24,000 because it's a straight line. It is always an outcome of 24,000. Your other one shows your increased tuition. So keep scrolling down until your tuition hits 24,000, which doesn't give you an exact decimal, but it will tell you after 12 years into the 13th is when it happens, which is our same answer, just not with the decimal. Algebraically is probably best, but a graph helps us kind of see it also. Let's transition a little bit. Go ahead and turn the page. Here's what our lesson gets into today. Solving, but certain types of solving. It says, solving a problem like the one we did in item 4 involves solving an exponential equation. An exponential equation is an equation in which the variable is in the exponent. Sometimes, maybe underline sometimes, because it doesn't say all the time. Sometimes you can solve an exponential equation. This is important. By writing both sides of the equation in terms of the same base. Sometimes you can solve by writing both sides of the equation in terms of the same base. Then use the fact that when the bases are the same, the exponents will be equal. So look up here. If I have 5 to the 7 equals 5 to the x. What's x? 7. It just makes sense. If they are equal and the bases are 5, then the exponents would have to be the same. What if I have 3 to the x plus 1 over 3 to the 10th?
9.
Doesn't this have to equal this for them to be equal?
No.
So once you get the bases the same, the exponents are going to have to be the same for them to be equal. This is possible sometimes. Sometimes if I have 3 to the x plus 1 equals 2 to the x, I can't get them both to be a base of 2. We'll discuss that next week. But today is they are going to be possible to write as the same base. So look up here. These are done in your book. I'm going to walk through how to do them. I would look up here instead of your book, but it's up to you. Here's the problem. 6 times 4 to the x equals 96. If there's any adding, subtracting, multiply, dividing going on outside of the exponent, you need to get rid of that. So we want the base and the exponent by itself. So we want to get rid of 6, of course, it's being multiplied. So you divide by 6 on both sides. Now the exponent is by itself. I want to get 16 to have a base of 4. How could I write 16 with a base of 4? 4 squared is the number 16. And now look what you have. The bases are both 4, so x has to be 2. And you can just check your work if you have time. Let's look through another one. This is also in your book. This one has no extra add, subtract outside of the base and the exponent. So you're ready to get them both with the same base. Pretty much always pretty much always want the smaller number to be your common base. So 5 and 125. I'm going to get 125 to have a base of 5. You would be allowed a calculator. We know 5 to the second is 25, so you wouldn't even type that. But you might type 5 to the third. Is it 3? Yeah, I'm cheating. So you would just keep going until you figure out, what do I have to have as the base and the exponent to get 125? In this case, I can rewrite this. The only thing I've changed is I've rewritten 125 as 5 to the third. Now recall a power to a power. What do we do with those? If I have 5 to the second to the third, is that 5 to the fifth or 5 to the sixth?
6.
Multiply, yes. So I have to multiply the 3 with x minus 1, which is 3x minus 3. I get the same base. Then I had to deal with a power to a power, which is multiply. They now both have a base of 5. So the exponent 4x must equal the exponent 3x plus 3. Comprende?
Comprende.
This does not work all the time, but when it does, it goes pretty quickly. And some of them you can do like this, maybe without a calculator, but you will be allowed a calculator for these types of problems. There are 4 for us to practice. Let's get started. What's the first thing you're going to do in example A?
-1.
Ooh, close. Add 1. I love when really smart people say things that they actually know. Like, all right, can I get 81 to have a base of 3? You would be allowed a calculator, so you try. Okay, we know 3 to the 3rd is 27. So it's got to be bigger. Try 3 to the 4th. If that doesn't work, try 3 to the 5th. Keep going. Tell me what it's going to be.
3 to 4.
I hear 2 different answers, so use your calculators.
I'm so stuck on the fact that I so confidently said 9.
James is a math guy.
What is it?
3 to the 4.
Okay, so I'm going to rewrite 81 as 3 to the 4th. So now I have the base of 3, which means the exponents have got to match also if these are going to be equal, and I'm done.
Oh, okay.
Oh, I feel like that last step.
See, I do the first one, I'm like, this is not so bad. And then I look at the next one, I'm like, maybe.
No. It's not so bad. I have 2 to the x. I need to write this as a power of 2. Think of it this way. 2 to what gets me 32? 2 to the 5th is 32. So 2 to the negative 5th is 1 over 32. So this can be rewritten as 2 to the negative 5th. And my answer is negative 5. You do have to show some work, even if you're like, but I know that. Okay, just take an extra 10 seconds, probably less than that, to rewrite what's in green, this part here. That won't take you 10 seconds, and then write your answer.
Somebody had to make these pages, and they said, show your work, and gave you no room to show any.
I know, I think,
That's like irritating.
Who did that?
I don't like that they wrote that, but if they left space for show your work all the time, that book would be twice as big. So you're right. They shouldn't say. They should say show your work on another piece of paper.
Right.
Right.
So just-
I agree.
Can't even write in like the graph paper without working the graph paper.
Yeah, why is this like that?
Well, there's something positive to say.
I like the color.
This is kind of easy.
That means save the planet. Don't use a straw.
Oh, excuse me. I like the color of this.
Oh, I was like thinking of like skipping over like.
Oh, we got a
A,
positive
like,
thought. We like the color of the book. It is very pretty.
I can't read it when I write on the graph paper.
Yeah.
Okay.
I love practice.
In letter C, are we gonna get the base to be 6
Yeah.
or 36?
6.
You could do either, but it's usually people do the smaller number. So we're gonna get them both to be a 6.
I want to know how to do it.
So I'm not doing anything with x plus 1. I'm changing the base, which is currently 36, to have a base of 6. So how do I do that?
Now multiply the exponents.
Well, what do I write here instead of 36?
Yeah.
6 to the x?
Sure.
No,
Two.
6 squared. Now they have the same base. But if you have a power, an exponent, to another exponent, go ahead and multiply those.
Then you cry. If I was right, I'm gonna put that down.
If you dropped the bases at that point, I'd be okay with that because they are the same. You just want the exponents the same. So it's 2x plus 2. And now the bases are the same. I'm sorry that there's not space. You might have to do it in the side. Or separate piece of paper.
Oh, and then they put the math tip right there, right next to it. So you can.
Yeah, they put the left math right there.
Horrible spacing on
They
their
couldn't
like.
put that
It's
anywhere.
just
Tries to be, like,
We should call in and tell them.
the person who did the.
I used to have a big note card of all of the errors I found.
That's so.
And then she ran out of room on that note card.
I think my note card fell out. Maybe I just wrote them in pencil. It's a big purple note card. It was like the biggest note card you've ever seen. It was like, have you guys seen a note card this big?
Like a piece of paper.
And it had lines on one side. Okay, do D. I'll do it myself. You do it on your paper.
Because I just don't have enough space.
2.
Where is it? Okay.
Supposed to look and then.
Wait, what?
I thought you looked up and then.
Oh, no, I kind of looked up, but I like really was not paying attention at all. So it's okay.
So the smaller number in terms of 749 is 7. So that's why I chose to keep 1 over 7 and 1 over 7 squared. So x equals 2. Remember, you can always check your work by plugging in x. C was 6. Here's your homework. You are allowed to use your calculator for the homework.
Oh, it is 6. Wow. I just finished it.
I didn't even finish it.
It just took me.
I got lost.
I got distracted.
Can we just be on break for the rest of the class?